Hello there. So I'm going to make a little video introducing the C programming language. Now, I want to say first, it's getting cold here, as you can probably see. I might put on the mask at some point. Please don't be triggered if you hate masks. I'm in Japan and we use them to stay warm in the winter, among other things. So, yeah, the C programming language. So that's not a good first language in my opinion. We'll discuss about that, at what point should you learn C, if you should learn C, what it's useful for, and all that kind of stuff. Of course, I'm going to give you a little introduction to the language. By the way, this is live, so people might come in and have some comments. We'll see about that. Questions, etc. I think that's helpful. And, yeah. So, also, this is going to be a light introduction. I just want to give you what you need to get started so that you have sort of the basic knowledge to sort of propel yourself forward. Because if you just look up C for a C programming tutorial, they might kind of assume you know a lot of things that maybe you don't. Yeah, so I'm going to give you what you need to get started. And also, I want to talk, like I said, this is going to be pretty light. I want to talk about some of the context here. For example, you'll hear words like Linux and Unix, and if you follow tech stuff or programming stuff, say on YouTube or something like that, you may see people argue over the definitions of these things, you know. So I just want to give you this introduction and give it to you with some context so you understand what the heck is going on. So let me first start by talking about who should learn C. Now, I like C. I agree with those people who say kind of every language kind of sucks in its own way. So unfortunately, there's not one language where it's like, oh, this is the greatest language to recommend. You got to start with this one. I actually, if you're starting out in programming and you don't know which language to learn, I'll make a suggestion which a lot of people are going to cringe at, and I would be kind of uncomfortable doing this, but there's a YouTuber called TechLead who recommends the same, and that is JavaScript. Hold on, JavaScript, all the languages kind of suck in various ways. The thing with JavaScript is that you could do stuff in the browser and put it up on the web and show your friends and all that kind of stuff. So I think the advantage of learning with JavaScript would be that you get, just this stuff where you can kind of see results quickly, cool results quickly. Whereas with C, in the beginning, you're probably going to be in some kind of terminal or command line, which we'll discuss what that is, that kind of stuff. Okay. And another thing, like some people out there, some of my viewers play Roblox, and actually, I think Luau actually is a great language. Luau is the Roblox version of Lua. And actually, Lua works well with C, as it turns out. But anyway, Lua is more of a scripting language, and C is a compiled language. I don't know if we'll talk about that, the difference there. Don't worry about it too much. Okay, so some context with the C programming language. It has quite a history going back. I think it was developed maybe in the 70s, early 70s, I'm not sure. Something like that. It's been around for many decades. I would expect... So I think the problem with learning C as your first language, well, if you know for sure that programming is for you, and without a doubt, you are going to continue forward with programming, then C is a perfectly good choice. The problem with C is, as a first language, is that it's going to scare some people. Some people will be scared away. And it has this sort of weird reputation as being black magic or something. But C, in some ways, is actually simpler than a lot of languages. And in other ways, more complicated. It's weird. I'm still on the journey of figuring these things out. The nitty-gritty details might be a bit more complicated because C is designed to work on all kinds of systems. I wouldn't be surprised if my washing machine runs code that has a chip in it and runs C code. I would expect that an airplane is running C code on it. Medical devices. Those are sort of everything I mentioned so far are embedded systems, where you have a chip in some, like this camera that I'm using right now, right? I don't know if it technically qualifies as a computer, but it's got computer chips in it for sure. So, and yeah, those are embedded systems. Operating systems are usually written in C, I would say. There might be some C++. It's not a rule that if you're writing an operating system, it has to be in C. But C basically gives you a lot of control, what we call low-level control, meaning close to the metal. It's close to having direct control over the CPU and RAM and the different components of the computer. So, whereas a higher-level language like, I don't know, Java or JavaScript or Python, those languages are they sort of hide away some of the details a bit. And so C is a great thing for learning those details, for those of you who want to learn how the nitty-gritty details play out, sort of under the hood, what's going on. So yeah, by learning C, you can learn a lot about computers in general, technology in general, and it's great for that. So I think I definitely recommend it for anyone who wants to be like an elite programmer or something like that. Or if you're kind of into math and you're kind of on the more like hardcore geeky side of tech and programming, I think you'll like it. Otherwise, it's as a career, I mean, embedded systems, anything to do with operating systems or writing drivers. So, all the devices like a mouse, a keyboard, etc. Somebody has to write drivers, which are sort of an interface for allowing the operating system and the device to communicate. So those are drivers. And all kinds of low-level programming, probably older stuff like banks and stuff use C, I would imagine. Yeah, so it's kind of more hardcore, if you will. And I do like it. I like C quite a bit. So there are some complexities. Okay, now a word on platform, because this is going to teach you how to get started. Kind of the easiest is probably with a Mac. But I am here with Windows because it's a little more complicated. With a Mac, so we're going to start in the terminal. And on a Mac, you can search the magnifying glass thing, Spotlight, is that what it's called? You can search for terminal. Or you can find somewhere in your system is the utilities folder and open up terminal. And or if you can't figure it out, just from that advice, just Google it. How do I open the terminal on a Mac? That is going to be, honestly, on a Mac, it's quite easy to open a terminal. And you'll have something like this. There'll be some kind of something, okay? And then there'll be this. This is basically a prompt. I can type things in. Like you can type in PWD. That will show you basically where you are on the system. Now, let me explain how to do this in Windows, and then I'm going to assume if you're on some more complicated platform, like if you're on Linux or something, I presume that you could figure it out on your own how to get a terminal emulator or something running. So I'm not going to talk about those platforms, so I'm just going to explain what I would recommend with Windows. Now with Windows, what I would recommend is going into the Microsoft Store and installing Ubuntu, which is what I've got here. So search for Ubuntu, install that. Now, it might have a couple bugs as you're trying to install it. So whatever happens, Google it, try to work it out. On my system, with my motherboard, I had to go into my BIOS and change one of the settings, I think, for it to work. So yeah, you might try to troubleshoot it or leave a comment if you still can't figure things out. And other than that, when I installed Ubuntu, and this has happened multiple times, it says currently installing Ubuntu. It comes up in this window like this, and then it just sits there forever. And so what I do is I load up Task Manager and check that this Ubuntu thing is using 0% of CPU resources. That means whatever it was doing is finished. And then I just press Control C. And Control C, like if I hit enter here, it shouldn't do anything. The command's not found. What would be an example? Well, anyway, anytime the terminal gets messed up, you can do Control C and it will sort of stop whatever's happening. So that fixes that bug, and then it will ask you to set up a username, password, and it's very quick. And then you'll have this kind of thing going on in Windows. So this is very similar to the terminal in Mac. So this is the first thing I want you to do, is to get the terminal set up. Now this is not strictly programming. What is the terminal? Basically, it's how people used computers in the old days. Even when I was a little kid, the first computer we had, I think, was an Apple II. There were no windows. There were no folders that you can click on. I don't think, was there a mouse? There might not have been a mouse even, right? I don't see what you would use a mouse for back then. So it was like this. You had a command prompt. And I would play these little silly games that my dad bought for me. And yeah, there were games on the Apple II, but you would have to use this. So this is just using a computer. The terminal, there's nothing magical about it. Okay, the command line or the command prompt or the terminal, whatever you want to call it, that came first. That was the first way that people used computers. It would just be like this, right? I just realized you cannot see the very top. So let me fix that. Oh, wait, what? What the heck? Oh, I'm pushing the wrong button. Hold on one second. So you can see the very top. There we go. Okay. So, yeah. Let me fix that. Okay. This would basically, minus this window thing at the top, when you turn on your computer, you'd have this. Or early on in Windows, they had just Microsoft DOS. So the point I want to make here is that when I was 7 or 8 years old, or even younger than that, I was using the terminal, the command line, and everybody did. If you wanted to run your games in the early days of Windows, all the games ran in, not all of them, but in the beginning, yeah, maybe all of them or most of them ran in MS-DOS, which was before you booted up the GUI, okay? All this stuff is a GUI, a graphical user interface. We have the mouse, we can click on things. So a lot of games would run in DOS, which has no GUI built in. So anyway, what I'm trying to do is tell people you shouldn't be afraid of a command line. It's just a thing where you type in commands. Back in the day, 6-year-olds were using these, so there's no excuses for you, okay? Some people throw up their hands, oh, the terminal, what? It's black magic. No. Okay, so the first command I want to teach you is this pwd. Now, incidentally, I will mention, just as bonus information, in Windows, you can go down here and you can open up the CMD. That's cmd.exe is the old school one. Now there's the PowerShell is the more modern command line on Windows. But things will be a bit different. I'd recommend PowerShell over CMD, but most of the stuff will be kind of the same, but some of it will be different. So I wouldn't really recommend it. I'd recommend doing what I did here. And this is WSL. What is WSL? It's Windows Subsystem for Linux. So we're running a little Linux instance here on our Windows machine. Now, another more fancy thing you could do, you could have a whole virtual machine, which it just sort of simulates a lot more stuff. It's like, if you want, a virtual machine is basically if you want to simulate a computer inside your computer. What we're doing here is a little more lightweight. Anyway, and we can have multiple instances of this. Like I can open up multiple windows of this. Okay, cool. So whichever system you're on, you should have a terminal. And so if you've navigated in your folders on your system, you know that there's this sort of hierarchical structure of folders, right? You can, you typically you have a home folder with some username, and then within that username, you could have your desktop folder, your downloads folder, and all that stuff. This is the same thing right here. When I type pwd, it tells me the current directory. Yeah. So there are a few more commands. Like there's maybe just like 3 commands you need to sort of know how to navigate around. But I'll teach you a few commands that are going to be useful. One of them is clear. That just clears the thing. Another command that's nice is ls. That sort of lists what is in the current directory. Now we haven't gotten to C programming in C here yet, but I think it's important for programmers to learn like some basic usage of a command line. Anyway, so ls will list in this directory that I have here, which is a directory I created called C. I have some files here already. Now what I'm going to do, let's see. I don't have a tilde on my computer is messed up because it's Japanese. I'm going to copy paste this tilde. Is this going to work? Yeah, it works. So I'm going to cd to this tilde. We don't need that slash, it's optional. So what this means, the cd command means change directory. And actually, and the tilde refers to my home directory. So it's changing directory to the home directory. Now by default, even without that, if you just type cd, it should go to home directory. So now I'm in the home directory. If I type pwd, it shows it. And I realize I should make this bigger for people. So one way to do that, you can right click, properties. I should be able to go to font. Let's just make this a lot bigger. Okay. Okay, so pwd shows the current directory. Since I did cd, I've moved into my home directory. Should I just make this full screen? Here we go. All right, so I'm going to clear ls. All there is in this directory is, and you don't have to follow along here. Just try to understand the logic that I'm explaining. And we're going to learn more by practice as we go. I'm in the home directory. Also, my prompt, this thing is called a prompt. It just gives me some information. And, right after that, I can type in commands. Now, it happens that my prompt gives this directory information. Again, the tilde is my home directory. If I do cd tilde, I can't type the tilde on my keyboard. I don't know how yet. Japanese keyboard. Anyway, cd tilde, enter. Nothing's changed. I'm in the same spot. Now another thing, so these are some, what do you call them? I guess shortcuts. Dot represents the current directory. So if I do cd dot, nothing's going to change. That's pointless. But I can actually go up by going dot dot. That represents the directory above. Don't worry if this is a little overwhelming at first. You'll get the hang of it. I just want you to be able to kind of navigate around your system a bit. These are just basic things that a lot of people should learn. So now I'm in this home directory. I can even go higher, and I'm in the root directory on my system. If I could do pwd, this is the root directory. And so if I try to go up higher, I cannot. This is the top. I can do ls here, and this is, yeah, in the very top directory, which we call it the root directory, but it's sort of confusing because there's another folder. By the way, folder, directory, same thing. Use them interchangeably. But there's another folder here called root. So you should call this probably slash root. That's the that's what it is. If I type in, or sorry, if I change directory to root here, well, it's actually permission denied. I mean, I know how to get in there, but I won't show you for now because it will be confusing. Where can we go? Can I go into MNT here? Yeah, let me go there. So MNT is where you're supposed to mount, like all these folders have different general purposes. Okay. MNT is where you're supposed to mount other things like, let's see if I have anything here. Actually, so on the WSL, this Windows subsystem for Linux, these are the actual C and E drives on my actual system. So if I go here, I can ls, and this is actually now my Windows system here. Some of it doesn't like me accessing, I guess. But we've got our Xbox games. I guess that's for Minecraft. And I don't know what this other stuff is. But, I mean, program files, users. So now I'm on the actual Windows side of things. So it's a little complicated. But I'm going to go back up here like that. And I'm sort of back where I was. I could have also, like, let's say I'm in the MNT directory and C or whatever. I can actually do, so you can always just type in the actual address or path where you want to go. So that would work here. This will take me back to the root directory. Or just as another example, I can type in home and then my username, and now I'm back at the home directory, my user's home directory. So I know that's a little confusing, a little overwhelming for a lot of people, but don't worry too much about it. Now what I've done here, I have this C directory. We can make a new directory. So now I would like you to follow along. So just type in CD so that we're back in our home directory. And now if you want to make a folder on your desktop or in your documents directory or whatever, like you can go like this or something. If you're on a Mac. Here on Windows, let's just make things here. So what I'm going to do is make directory. So remember the ls command, just in case you don't remember, it just lists what's in your current directory. So you didn't need to do that. I just do it by habit all the time. Make dir command is going to make a directory. So I'm going to call mine this C tutorial. But you can call yours whatever you want. And what you can actually do, I don't have to type it out every time. Once I've put in enough, I can just press tab. And it will get me there. However, you'll notice that there's two folders now that are that start with C. So if I type in C and then press tab, it actually doesn't know which one I want to go into. You can press tab twice and it will sort of list them out for you. I need it to give it a little more information, and now I can press tab and go into the other one. If instead I just wanted to go into the C directory, well, this is enough. Okay. So again, make sure you're in the home directory and make something, whatever you want to call it. I can do this again. It's not going to... I already have this directory, so it gives me a little error, cannot create directory because it already exists. Note that it says file exists. There's this thing in Linux, I'm on Linux here, where everything is a file. In fact, it might be a Unix thing. So we'll talk at some point about the difference between Linux and Unix, or at least I'd like to talk about that. I don't know if we'll really have time. Okay, but I'm going to go into this directory by cding into it. Change directory into it, and I press ls, and I notice that there's nothing here. It's empty. What I can actually do is I can give some options to the ls command. Let's try just with the A. What this does is it gives me all. So there's actually some hidden things, and what the hidden things are, you can think of it as kind of as a shortcut. There's something here representing the current directory. Remember I said dot is the current directory. If I do cd dot, it's always going to do nothing. I can also do things like ls dot, which is identical to saying just ls. You see what I mean? Like this is, I'm saying list out what's in the current directory. Doesn't matter. So the dot dot is the directory above. So you always need, the idea is that no matter where you are on your system, you can always go back up. You're never going to get completely lost. So like if I do ls dot dot, it's going to list out the stuff in the parent directory, which was these two folders, directories. So let's get a little fancy. Let's go back up. I just also want to show you how to create a file in general. We can use this touch command. This will create a file. You can name it whatever you want. I'm going to name it my file. And I'll note here that really, from a programming point of view, file extensions kind of don't mean anything. These file extensions, sorry, my camera dies after 30 minutes, I guess. These file extensions are basically a hint to the operating system. So it doesn't really make much difference from a programming standpoint whether I have some kind of ending file extension thing. Basically, that's only going to make a difference if I actually open the thing. So, but let me show you something else. So if I do ls here, you can see that the file is here. Now, I can also, in WSL, this is not, so if you're on Mac, you can do this, and it will open up the current directory in the, what's it called? Finder, right? On Windows, you have File Explorer. On Mac, it's Finder. But here, with what I'm doing here, we have to go like this. So this will open up the current directory in File Explorer on Windows here. But you see, there's some hidden files. I know that's really hard to see there. Can I make it bigger? Anyway, there's some dot files, meaning those are hidden files. And then you see there's a C, and then the ctut, and then myfile.txt. So I can double click here on myfile.txt, and the operating system knew that, well, the .txt is just telling the operating system, hey, this is how you should treat this data, because the file was completely empty. There's nothing inside of it. Okay, so I know this is overwhelming, but maybe watch this a few times, and then gradually things will make sense, and practice. And yeah, this is how we do things. Practice and practice and practice. All right, so I just wanted to show that we can open this. That's all. I want to go back to the terminal, actually. And there were, as you can see, there are all these hidden files. So again, ls-a will show everything. In the Linux world, we call these dot files. So I don't know if Windows people call it that too, maybe. But that's a bit cluttered. Another thing I can do is I can do A and then also add another option. We call these flags or options. So we have this A option and the L option. The L is going to sort of list things out. So it's going to be vertical like this. So these are all the files. Let me let me turn off the camera real quick. Okay. So you can see all these files. And we have a bunch of extra information here. Let me just make this smaller. Oh. Let me make this smaller. So what is all this crazy information? Don't worry about it so much right now. Yeah, don't really worry about it. It's kind of, it says UV here. My username is UV. There's also root. So these dots were created by root. So there's always a root user. That's sort of like the admin that can control everything. But don't really worry about that right now. Let's just do ls again. And so not counting all the hidden files, we just have this file and these two directories. So I'll go back into the tut thing. And if you ever get lost somehow, you're trying to follow along, but you navigate somewhere crazy, just type in cd, go back to your home directory. If you want, you can type pwd. That tells you exactly where you are. And you can ls, you can cd into something. And here we are. Okay, so that's basically most of the terminal stuff I wanted to say. Let's talk about actually writing C code. Now, again, what I can do to create a file is this touch command. It's called touch because it not only creates files, but if a file already exists and you do touch on that file, what it does is it updates, like every file has some information of when it was last edited. Like you see is November 19th and the time and everything. It will update that. So it's like it's touching it. And so the information of when the file was last changed will go to the current time. So that's not really important. But that's why it's called touch. We use touch to make files. So let's do our first one, and we call it main.c. This is sort of just convention. Call it main.c. So ls, there's my main.c. I can get in more information like this. Or there's also the number 1 here. I forget what that does. Oh, that will list things out vertically, but with less information. So if I had more things, don't follow along. Just here's the 1 flag. You can see it's vertical now with less information. Okay. So back to where we were. We have this main.c. So we want to. So the .c again. It's just sort of convention. It's just saying, hey, everybody, this is text, which we're gonna treat this like a like C code. Now, in case anyone's confused, code is just text. So a lot of times you'll have people who think they need a crazy system with 32 gigabytes of RAM and an amazing graphics card and all this stuff so that they can do programming. Now, if you're doing Mac, if you're doing like you want to make apps for like iPhone apps or just programs on Apple devices of any kind, you might need at least 16 gigabytes of RAM because Mac stuff, they force you to use Xcode, and Xcode is pretty bloaty. It's, yeah, in that case, you might want some more. You also have like if you're doing iPhone stuff, there'll be a simulator that emulates the iPhone and all this stuff. Or if you're doing game engine stuff that's pretty heavy duty, then sure. But most coding is literally just text editing. So I kind of laugh at people who say like, "Oh yeah, I want to do programming, so I need this. I got this, crazy graphics card, and you definitely." I see people sometimes say like, "Oh, you definitely need 32 gigabytes of RAM if you're gonna do programming." Bro, you need like 8 megabytes of RAM. You just need to be able to edit text. Anyway, so that's what programming is. It's editing text. So to edit text, we need a text editor. And here's where things get a little tricky. We have a couple of options here. By the way, I should have said, okay, you're going to need a compiler. And so what is a compiler? That's the thing that takes code and turns it into a program. So if you are on a Mac, you should use this compiler called Clang or Clang. I'm not sure exactly how you're supposed to pronounce it. I'll call it Clang. It's a little easier. But here, if you're following along on Windows here, we're going to use GCC. And the way that you do that, there's a few things that you should do. Don't do this yet, but to get GCC, you would do this command. However, you probably should update your system here first. So I'll show you how to update the Ubuntu system here. The first thing you do is called update, and amazingly, that does not update anything. It's fantastic, isn't it? But anyway, sudo apt update. This sudo is a command that we are going to see quite a lot. Programmers use it all the time. And it stands for super user do. So remember I said there's a root user? There's always a root user. It's like the admin. It's like the king who has full control of everything. Because we're installing something, we want to do it as the root user. So there are ways I can change my user to being root, but that's a different topic. When you want to execute one single command as root, we use the sudo or sudo command. People pronounce it different ways. I think I'll probably pronounce it sudo, although technically maybe sudo is better, but it doesn't really matter. So don't do this if you're on Mac. It's just not gonna do anything. It's gonna give you an error. But I'm gonna run this. It's gonna ask for the password. Whenever you set up the system, it would have asked you, when you installed it, it would have asked you what password you want. So I'm typing my password. So what this update thing on Ubuntu is, all it's doing is like it has lists of what are the latest packages, right? So the operating system has lots of packages. Our C compiler is an example of a package. It's basically, yeah, it's like an app or something, you know, it's a package. So by doing an update, we've just updated the list of the most recent packages. I haven't actually updated the system yet, so it's a little confusing. Bad terminology. We have to do sudo apt upgrade. By the way, you can push up in a terminal to go to previous commands. You can also type history, and it will tell you all, you know, these previous commands. Sometimes it will show you, like, let's say I do a session, let's say I close this and open it up again, and then I type history. Sometimes it will show me everything that I was doing before, and sometimes it won't. The reason is, the hidden reason is that there's actually multiple terminals. I forget what they're called right now. Don't worry too much about that. But if that really bothers you, just Google it. There is a way to get it to where you have like a shared history between all of these terminals, basically. But anyway, so there's the history, okay? But you can press up, and you see it's showing me the other ones. And so to finish updating here, we need to do sudo apt upgrade. And I recently, I did this earlier today, so there's nothing I needed to do that for. But in sudo apt install GCC, here we'll install GCC, which is our compiler we're going to use. If you're on a Mac, what I would do is type in clang and see what kind of output you get. You might be able to do this, and it's supposed to give you a version. I don't have it on this system, but if you're on a Mac, either maybe Google, how do I check if clang is on my system? And if it's not on your system, then look into how to install it, because you're going to need a compiler. You could also install GCC on a Mac, but I would not recommend it. The recommended one is clang. And if you have two compilers, it can maybe get a little confusing. So I'd recommend that you just use clang if you're on a Mac. But so whichever system you're on, we have a compiler now. Cool. Yeah. So I'm going to clear all this madness. ls, see what's here. We got the main.c. Then, okay, we want to edit this text. We have a couple of ways to do it. I feel like there's an earthquake coming. No, I think we're good. I think there's a truck. So one way, you can literally open it up and edit the text. I mean, text edit is a viable thing that you could use. Now it's asking, because it saw the .c thing, it's suggesting this, which I have on my system. I could use Notepad. You can do that. I kind of don't recommend it. It doesn't matter. Again, it's just text. There are some things where you don't want to use, there's some kind of rich text or something, which you want to avoid. So actually, let's just check something. Let's open with, yeah, Notepad. Does it have something about rich text? I think Notepad might be okay, but WordPad I think is bad. So the rich text is like it adds in more formatting information and stuff that makes it not viable code. But we can actually use this. Now, maybe I'll start with this, but I will show you other text editors. But we can do this. So as practice, let's type out the most basic program you could have in the C programming language. So we're going to type this out a few times, and I'm going to explain it afterwards. First, you should just kind of try to memorize it, basically. So int space main, then parentheses like that, enter, curly brace, enter, tab, return, I'll explain all this later, 0, semicolon, and end curly braces. This is the simplest program in C that you can have. So I'm going to press Control S to save. I'm going to close this. And now this should be in this file. How do I check from the terminal if it's in the file? There's a command called cat. I forget why it's called cat. It's not a bad name though, huh? I'm going to do cat main.c. We can see that there it is. Notice that there's no end line here, so it didn't care. It just kept going. But it's actually fine. So this is the simplest program we can have. Let me explain it. I think this is basically the point of this sort of lesson here today, but it's just getting started here. This is your first program. Later, you know what? I might show later how to like add some numbers and stuff like that. But anyway, so what is happening here? So what's happening here is we have a function called main. What is a function? A function is just a block of code. It's a bunch of code, and the reason what's useful about it is it has a name. In this case, the name here is main. And by the way, these don't have to be the same. It's sort of nice that they are the same. The name of the file and the name of the function here, but they didn't have to be. But anyway, this is normal C. Every C program needs a main function. And yeah, so a function is a block of code. That's it. So every C program starts by finding the main function and then doing whatever is in these curly braces. Okay? Now, why does it say int? Int means integer. And what it means, every function has a type. This is going to be really overwhelming at first. But just try to be a sponge and absorb as much as you can. If I continue with these sort of tutorials or whatever, I'll probably do a few. But you need to be exposed to this multiple times and practice a bunch, and stuff will start making sense. In the beginning, it's just confusing, but it's okay. Don't be worried that you're confused. Just try to listen, try to be a sponge, try to take in as much as you can. So main is a function, and it returns a number. You see that right here. It returns a number. Specifically an integer. So what does that mean? It could return a negative number. It could return a positive number. But it's not going to return some kind of decimal number like 0.03 or something. It'll return numbers like -5, 0, 7, 2, not fractions. Okay? Those are the kinds of numbers. Yeah. And there are limits. We can't just put in like 80 billion trillion as the number. That will cause what's called overflow. Don't worry about that. But there are limits. It depends on how many bytes an int is. We'll talk about that later. Don't worry about it. Just know that yes, there's a size limit here. Okay. So it's a function, meaning a function, the idea here is it's something that does something, right? You have a function that does this thing, you have a function that does that thing. And in the best of worlds, you just look at the name of the function and you kind of know what it does. Like let's write some other functions. So what I'm going to do, I'm going to add to this code, and you can choose to use the same method as before of actually editing text in your operating system of choice, or you can follow along, and I'm going to use a text editor. Let's start with Nano because it's a little easier. There's a text editor called Nano. So I can open up main.c in Nano like this. Enter, and now here we are. It looks a little weird, huh? So, but I don't think I can click. I can actually click, but not everyone can do that. So I'm going to use the... Yeah, actually it didn't do anything. There's no mouse input here, okay? I'm using the arrows, and basically I can just go somewhere and type. Cool. And you see down here, the write out, that's how we're going to save, and this caret symbol means control. So if I want to save, I do control O, and file name to write, main.c, enter. So it wrote it, even though nothing's really changed. And we also have, when we want to exit, we have the control X will exit. So what I'm going to do, I'm going to go to the top, I'm going to press enter. I'm going to write a function. And let's make it an integer. So I want to write a function that adds 2 numbers. I think that might be a little complicated though. Okay, let's not do that. That'll be introducing too many things that are complicated. So I've pressed tab, and I can type here. So let's do some addition. So let's make a variable. I'll call it int x, and I'll say that it equals 0, semicolon. So what is a semicolon? A semicolon is like the period at the end of the sentence. It says this is the end of the command. If you leave that out, the compiler will not know. It might think that we're going to continue down here. We're going to continue. Yeah, it might be confused. So when we write a statement, we end it with a semicolon. It's like a period at the end of the sentence. And different languages are different how they do this kind of thing. But many, many languages borrow from C, or sort of use C as a starting point. So what we're doing here is we're creating sort of a variable called x, and we're setting it equal to 0. So one of the things I think is confusing for people in the beginning is, like, in math class, these are equations, but we don't have equations in programming. What we have is there's a thing called x, and we're shoving 0 into it. So it's sort of like, it almost goes right to left here and takes 0 and shoves it into x. X will be a specific byte in memory. A byte is 8 bits. So it's a specific place in memory, and it's putting 0 there now. Which means that, so if it's 8 bits, it would be like 1, 2, 3, 4, 1, 2, 3, 4. It'll be exactly that. Yeah. Okay. So there's x. And actually, let's make x 2. And let's make y 5. And now let's say, I don't know why it's doing this weird highlighting. We'll just ignore that. I don't use Nano usually. I'm going to show you, after this, I'll show you Vim, which is a different text editor. That's the one I normally use. Now let's return x plus y. So we should get 7, right? It should add these together. So I'm going to do Control O to write out, enter, and then Control X to exit. Now just to verify that that worked, I can cat out. I can cat main.c, and we see that we have indeed edited. I added some space here apparently. Whatever. Okay, and now we need to actually compile this program. When we compile it, it will form a program. A program is just something that runs on your computer. So whatever your compiler name is, it could be Clang, but here I'm using GCC. I'm going to do that, and then the name of the program. Enter. Seems like nothing happened, right? Well, if I do ls, it created this a.out. This is the output from the compiler. And to run this output, I do ./a.out. This dot, remember, is the current directory. So it's saying a.out in the current directory. It will run after I press enter. Get ready? Enter. Nothing happened, right? We didn't actually tell this program to output anything here. Here, this is called standard output, and we have not actually outputted anything to standard out. But shouldn't we be able to get a 7 somehow? Well, yes. So there's this magical thing. Just consider this command to be magic right now. I mean, I kind of still think of it that way. We do this command, we will get the 7. So this command, this magical command, will display whatever the output of the last program was. And this output of the program is used sort of as a signaling mechanism. So an output of 0 means that the program executed and finished without any problems. And then there's a bunch of other numbers that could be outputted that are supposed to signify that there was some kind of error. But 0 means no error. And so that's sort of a convention, right? So we have these conventions. So now I might talk about this sort of like some of the context here. So here's what I'll say. Wouldn't it be nice if all computers sort of worked in the same way, so that when you use different operating systems like Windows, Mac, Linux, whatever, so that you don't have to learn new things, right? That would be nice if everyone had kind of the same standards. Well, that exists. Those kinds of standards exist. But the thing is, Windows doesn't follow those standards and doesn't care. So Windows is always doing their own thing. And so one of the standards, so it's sort of a standard, is called Unix. We'll talk a little bit about that, because it's actually, explaining what Unix is kind of complicated, because what Unix is has changed over time. There's sort of a history there. And I'd like to explain what Linux is. So what Unix is, what Linux is. And there's another, I'll just throw out another couple of words here. There is a sort of convention for how, like, various standards for computers so that they can communicate and kind of work in the same way. Those are called POSIX. You can look it up if you're curious. I just want you to have heard of it. It doesn't really matter. There's sort of an organization. I believe is it IEEE? Some engineers that get together and decide on certain conventions. But again, Windows just chooses to ignore all this stuff. So that's why Windows is quite different. But then people think that there's like Winix, that there's Windows and then there's like Unix and that's it. But it's not like that. There's Unix and Linux are not the same. They work very similarly because, again, everything that's not Windows sort of follows these conventions, as far as I know anyway. There's another thing called BSD, which is more obscure, but that's another thing. It's pretty rare, but I think they also follow these. So we'll call them Unix-like standards or Unix-like systems. So you can say that Linux is Unix-like. And sometimes people will write *nix to mean Linux, Unix, and maybe some other things. I don't know. And if so, okay. So Unix historically, again, this is just context, because you'll read about this stuff, you'll hear about it, and it's very confusing. So I'd like to just briefly explain a bit of it. Unix was a specific operating system, I believe, developed in the 70s. It was around the same time that the C programming language was being developed, or maybe it was the first one that was I think maybe C was developed in order to write Unix, maybe. But these were developed at a place called Bell Labs, which was the research division of AT&T. AT&T was this enormously powerful company because the United States government gave them permission to sort of be a monopoly in a lot of ways, rolling out telephone capabilities for America. This going way back. So AT&T became this enormously huge, powerful company, and they had this research division called Bell Labs, and that's where a lot of this stuff was developed. So it's important for the history. So anyway, they developed Unix, and it had all these nice commands, like ls and pwd. I don't know if it had it like when the history was of how these things rolled out, but all these kind of commands, they're basically Unix commands. Okay, so I kind of expect these commands to work on any computer system except not really Windows. Now I'm on Windows here, but we're running Linux on Windows, right? And if you went back maybe 15 years, you'd probably have to use a virtual machine if you wanted to do this stuff in Windows. Microsoft kind of realized that nobody wants to use the stuff, the CMD and the PowerShell stuff that they've made. And so they created there's actually a Windows terminal which probably has these commands, but I would recommend using Linux here because you can install things like GCC and stuff like that. Yeah, so I know it's a little confused. It's very confusing, overwhelming. But what happened is, this is a very long story short, because AT&T was heavily subsidized by the government and given this kind of monopoly, there was a deal where whatever they developed at Bell Labs, they had to make like very easily available for people. So there was a time, like in the early days of computers, where a computer, like the only people using computers were the government, big companies, and universities. Because a computer would cost like $100,000. They'd be super expensive in the beginning, and they'd take up lots of space, right? But people wanted these for various reasons, maybe scientific reasons, whatever, and computing things. So again, they don't have a graphics user interface. They just have this sort of command line, but they wanted some kind of operating system, right? You need something like all this stuff that I've been doing here. You need something coherent so that you can use the darn computer. Okay. So Unix was made for that kind of reason. And so there was a time when universities and so on would spend enormous amounts of money to have a computer. And then I think they'd have to pay like $100 to get Unix or something like that. There's something weird going on like that. And so it was eventually kind of ruled that Unix had to be readily available and not very expensive. But the thing is, it's still proprietary. So some people wanted to basically sort of clone all the Unix stuff, make it their own. And the most successful example of this is GNU. Sorry, I bumped the mic. GNU stands for GNU is not Unix. That's what it stands for. GNU is not Unix. And they wanted to build their own operating system. The guy in charge of this was Richard Stallman. And the hardest part in building an operating system turned out to be the kernel. And the kernel is this thing in the operating system that controls, I think it's just mainly just the CPU. And it just handles multitasking, basically. And so this was very complicated and difficult to make. And this guy, Linus Torvalds, made the Linux kernel. And later, the GNU people said, oh, wow, this is really good. Maybe we should use this. They had their own efforts of making their own kernel, but they were having too much trouble with it, so they decided to use the Linux kernel. So technically speaking, Linux is just a kernel. Just this tiny part of the operating system. But very important part. So some people call it the GNU Linux operating system. But So right here we're using Linux, okay, but there are graphical user interfaces that you can use with Linux. So let's say, yeah, I'm just Googling Linux here, and if we go to images, you have a bunch of sometimes. So what are they called again? Desktop environments. Some of them are like really bare bones and they're just window managers. Let's see if we can see one of those. If I type window manager, this is just general computing information. If you want to be savvy with this stuff, it's good to know. So you can see here, this person's using a window manager. It's much more lightweight. They've got 3 terminals open, actually. This is just nonsense to try to look cool, to be like the Matrix or something. And this is HTOP, which is sort of like the task manager or the activity monitor kind of thing, showing CPU usage, memory usage, and so on. These are the processes that they have running. They've got Firefox running, that kind of stuff. So this is Windows Manager. It's like very bare bones, whereas the other desktop environments are more sort of similar to a Mac or Windows. So that's all. So Linux, because it's a free and open source. It's free and open source software. So FOSS, we say. And because of that, people play with it, tinker with it, and make their own versions, their own flavors, and we call those distros for distributions. So there's lots of different distros. One of them is Ubuntu. That's like the most famous. But Ubuntu is a little boring, to be honest. Like if you're using it for your own computer, and you can use you can choose pretty much any desktop environment or window manager that you want to use with Ubuntu, but not within WSL. If you want to do that, you should install Linux on a computer from scratch. You can watch videos or look up how to do that if you want to do it. But anyway, with WSL, we cannot open graphical applications, really. Last time I checked into this was maybe between 1 to 3 years ago, so it might have changed. There are some efforts sometimes where you can open, applications that use graphics from here. Yeah. I mean, I have it set up on my system where I can open VS Code here. And so here's our main.c right here. However, I think you have to set that up. Obviously, you have to install this software, which is Visual Studio Code, which is different from Visual Studio. It's very confusing. There's Visual Studio, and then there's Visual Studio Code, 2 different pieces of software. Visual Studio Code is more lightweight. Visual Studio is like pretty heavy duty. And because it's heavy duty, it's called an IDE, which is an interactive development environment. And those are sort of bloat. They're very heavy duty. I wouldn't recommend them in the beginning. It kind of depends on what you're doing. Whatever tutorials you follow, some of them will use IDEs, some of them will use the terminal like I'm doing. It's just different ways of doing things. You might want to learn different things, but don't get too stressed about it. Again, programming is just editing text in the end. So let's get back to the editing of the text. Again, we had this a.out. We were able to echo the return value of the program. Cool. So now I'm going to dive into using Vim. Now Vim is a serious can of worms. It's even very difficult in the beginning to exit the program. So exercise caution here. I'm just saying Vim might not be for you. But I did go to a programming school once, and I was actually surprised how everybody just started using Vim. And once you figure out the basics, it goes a long way, and it's much more comfortable than using Nano. It's much more powerful as well. So I'm going to open up this main.c in Vim. This is just a text editor. Now, there's a bug with WSL. It's kind of a bug. I'm just thinking, should I show you how to fix that? Probably it's going to say replace at the bottom. What I want you to do is press escape once or twice until that's gone. Okay, if you're on WSL. If you're on Mac, you might need to install Vim. Or, yeah, install Vim if you want. There's package managers on Mac. The main one is Homebrew. You could do it that way. Or you could just use something like VS Code. You can use the VS Code on a Mac. You might prefer that. Anyway, again, we're just editing text. Don't get bogged down with the text editor. It's just editing text. Don't worry about it so much. Like with more complicated programs, there are some fancy things built in, but we're editing text. So don't get bogged down. Okay, so we have some basic stuff here. I mean, this is kind of almost really good enough for this tutorial, frankly. Yeah, just to I think this is good enough. If I make another video here, I will list out like a bunch of there's a bunch of obvious things you can do. Like here we added some numbers, right? If you're talking about adding, multiplying, dividing numbers, like your basic arithmetic kind of stuff, that's kind of the next thing to do probably. And it's sort of straightforward. It's mainly just learning the syntax, which means how things are written. And then another thing that would be nice is to be able to output text to the standard out so that our program will actually output text. That would be cool. But yeah, I think this is kind of enough. Just to demonstrate Vim and just to show a little bit more, I'll add some stuff here. And I think I'll, again, kind of reiterate what this is, the int main, and then I'll close out the video. And please do leave comments. Likes help a lot too. Sub if you want. But yeah, feel free to leave comments, asking questions, anything. I'd love to hear what you have to say. I know this is, again, confusing. So I just pushed... Okay, Vim is complicated. You should you should spend some time learning Vim if you want to use it. You can push... There's a few ways to go into some kind of insert mode. So I've just pushed A. And this is now insert mode. If I want to leave insert mode, I press escape. And O also enters insert mode, but it creates a line below. And then I'm pressing escape to exit insert mode. And then I just goes straight into insert mode. The difference between I and A is like append, and it adds a space. A adds oh no, it doesn't. It enters insert mode and it moves a space. So almost the same thing. So I'm going to press O and then tab. Now we're in insert mode. Make sure you're in insert mode here to follow along with me. I'll show you later how to exit Vim. Yeah, it's a bit of a learning curve with Vim. It's a bit weird. Okay, so let's do this. Let's make a variable called out. So I can just say out. Now we wouldn't, like some other languages, you can just maybe do something like this. But in C, we always need to say what kind of variable we're talking about. And we've only seen the int. We'll see more later. But I'm making one called out. Now here, what I did with X and Y is I declared the variables and I assigned them at the same time in one line. Here, I'm just declaring the variable. I haven't set it to anything. And so what will actually happen here, it's probably going to initialize it to 0. but I wouldn't feel safe relying on that. There might be, wherever that space is in memory, might have garbage information from that a previous program had been using. I don't really think that's going to happen. But I just think it would be very strange to use this variable without initializing it. So the initializing is to set, give it some kind of value. So I'm going to set it equal to 0. Okay, and now I'm going to say out equals x plus y, semicolon. So now out should be equal to 7. And then here I'm going to say return out. So it's going to be the same thing. So let's just change a number so we get a so we know that we can check that things are working. I'm going to press escape, and then there's a few ways to exit Vim. Colon X will write and exit. You can also do colon WQ will also write and quit. X is just a faster way of writing the W and Q here. So this is like a command in Vim. So Vim has commands, which makes it rather powerful. And a lot of like shortcuts and things. So I'm going to do that. We can cat out our main.c. Again, I have all this space in the front. I don't know why, but it doesn't really matter. Again, I'm going to compile. If you're on a Mac, use Clang instead. Now it's overwritten, should have overwritten the a.out. Let me show you how to remove something. This will remove something. RM for remove. So the a.out is gone. So now we can just be sure that there's no chicanery, no weird things going on. We can make sure this is indeed the new a.out. So I'm going to run a.out like this, and then I'm going to echo out the return value of the program, like this, I believe, was it? No, it's a $sign, isn't it? Enter, and we get 8, which is what we expected. I'll just briefly say, just last thing, I'll again go over what this does. Just this is review, but I think you need to hear it a few times before it's going to really stick if this is new to you. So this is a function, it's a block of code, and every C program needs a main function. By block of code, just think it's a bunch of code. Okay, this is a block. The stuff that's inside of these curly braces, okay? And so every C program needs a main function. That is where command, well, it's not, we don't call it command execution, but that's where code execution begins. So you can kind of think of it logically. It will go in through here step by step. So the code execution actually doesn't start up here. It actually starts here. Yeah, because it starts at the beginning of main, wherever that is in your program. You could have lots of text, all these crazy things going on, and the program will start right here at the beginning of the main function. The int here tells us what type, tells us the type of main. And so it's an int, meaning that it returns this integer. Again, might be a little confusing, just be patient. So we have a variable called x that we're assigning to the number 3. We're assigning the number 3 to it. So we're setting x equal to 3. Same with y, but we're setting y equal to 5. It's not... Yeah. It's going to take a while for some people before to divorce themselves from like the world of mathematical equations, but Anyway, there's a variable called y, and it has 5 there. Here we declare a variable called out, but we do not assign a value to it. And here we assign the value 0 to out. Notice that we don't need to write int again, because you only need to do that when you declare. So in these 2 lines, we're doing declaration and assignment in 1 line. Here, these are just 2 ways of doing very similar, the same thing. Here we're doing declaration here, and then assignment in 2 separate lines. Both are okay. And we again assign to the variable out, but we assign it with whatever x plus y is, which happens to be 8. And then finally we return. And then even if we had written stuff after this, when main returns, when the main function returns, the program ends. So this will end the program, even no matter what we have written after here. Now, if you put nonsense after here, the compiler will complain, and if you have a typo, the compiler might throw an error. That's why sometimes it's good to remove this a.out and pay attention when you do the compilation to what kind of error you have. There's a tendency for beginners to ignore errors. Because the error, don't follow along. I'm just going to demonstrate what an error might look like. So I'm going to go in here and just type some nonsense. Now, I'll try to compile. It gives me errors. So notice more than one error happened for some reason. But so there's a tendency. So this looks like a complicated mess that they're telling me, right? So a lot of newbies, a lot of beginners will receive errors and then just ignore it and then go back to their code and try to fix their code. I've seen that. Even people who've been programming for months, like nonstop, they still have this bad habit sometimes of not listening to the errors. Errors are extremely useful information. I mean, right here it says unknown type name, blah, blah, blah. So the problem is that I've written this thing that's nonsense. That's what it's saying. And then that problem then caused a couple of other problems. And I don't really understand what this stuff is about. And I don't really care, because it was caused by this one. There are sometimes there can be compilation errors where the information they give you here doesn't really explain it very well. So let me see here. I might try to give you an example of that. For example, I'm going to delete that line. Suppose that I forget a semicolon. Let's see what happens here. That's definitely a bug. That's definitely an error. But now let's see what happens when I try to compile. Okay, it actually does a good job of telling me. I was just thinking that there's some problems that can happen where it's actually the line above that caused the problem, and it can be it's not super obvious right away, like what the bug was. But generally, the output here is very helpful, and if you're confused by what you're seeing and you don't understand it, you should copy paste it into Google. Now, of course, sometimes you look at your code and you see, oh, there's an obvious typo, or you obviously know how to fix it. But if you go a few times and you don't know what's going on, listen to the errors. I'm just saying, because some newbies, they will keep trying to fix something and they're not actually listening to what the error is. They're not thinking about how this error is arising. A more experienced programmer, like I had someone trying to help me, and they weren't looking at the error, and I was being polite. They were kind of like overbearing and trying to fix something for like 20 or 30 minutes, not listening to me, because I kept saying, well, the error was this thing, so it can't be that. It has to be I kept saying like it has to be this thing because of the error, and they just weren't listening. So, and I wasn't like, I was just waiting for them, you know. I'm like, oh, they're gonna learn. We went like 20 or 30 minutes, and I kept saying, you know, it's probably got to be this thing because of the error that we saw. And they were so focused on reading my code, I think, that they just weren't listening to what I was saying. Yeah. Anyway, with experience, hopefully you'll learn that, but try to improve that way and make sense of the errors that you're seeing. Now, there's also warnings that can come up, and the difference between a warning and an error is that errors will cause the compilation to fail. Warnings, the compilation will still compile. Well, it will still compile with a warning. Okay, that's the difference. If it's just a warning, then the compiler is saying, it seems like there's something wrong here. Are you sure about this? But it will still compile for you. The error means that it cannot compile. Now, why do I like to often remove a.out before compilation? Just because if I weren't paying attention, maybe I would compile, there would be an error, and then without really paying attention, I would still... This a.out here is from a previous version. So I might confuse myself. So sometimes I like to remove the a.out and then compile. And there's no way, if I try to run a.out, it doesn't work. No such file or directory. It doesn't exist. It didn't compile. Bash, that's going to be a word that we're going to talk about in the future. Don't worry about it right now. Bash is the name of the shell script. Right here, we're in a shell. You have a lot of names for it. Terminal, command line. Sometimes people might call it a terminal emulator. You can also call it a shell. The shell is like Ghost in the Shell, huh? Well, that just means the normal version of shell. I think there was a sort of a wink to programming world with that name. But anyway, the shell, so you have shell scripts, shell languages. It's running bash. So there's actually a programming language here in the shell. So I could actually add numbers and do programming stuff right here on this command line. And that would be using the shell script that's here, which happens to be bash. There's other ones. What's popular right now? ZSH. Actually, on a Mac, it will be ZSH. So there's some small differences between ZSH and bash. I just want you to know about that. Just be aware of that. It's a shell script, shell language. Also, I'll just say the C programming language is a compiled language, which is what we're doing here. We're compiling, which means that, for example, the compiler can look through your code and figure out, oh, we can make things more efficient, more optimized by doing things this way. So it takes the time to look through and figure stuff out. So that's kind of normal. But there's another type of computer language programming language called interpreted languages. So Python usually is an interpreted language. I think you can do things to use it through compilation, but usually Python is interpreted. And with interpreted languages, Lua is also interpreted. Interpreted languages go one line at a time. There's no compilation step. So if I were writing Python, there's no compilation. I write Python and I run the Python directly. So don't follow along, but so it might be like this. So you have main.py, and I would just run it directly. So I would like do Python main.py, and that would just run it. You see, so it's skipping this GCC step. You're just going directly and running it. Because interpreted, just boom, one line at a time. But that means that there's less possibility for optimization. That's why generally interpreted languages are considered slower. Compiled languages are considered faster. Why would you ever want an interpreted language rather than compiled? Good question. I don't really have a good answer, but something like Python or Bash also is interpreted. These shell scripts are pretty much always interpreted languages, as far as I know anyway. Thing with something like Python, it's easier to write. But, yeah, I don't know. It's an interpreted language. It's going to run slower. It's just, a lot of things are like way slower than C or C++. Like 100 times slower, 1,000 times slower for certain things. And other things are pretty much probably the same speed. And then there are certain libraries and things that use Python sort of as hooks. So what it means is you write in Python, but the library, this tool that you're using, actually is written in C or C++. It's written in some highly efficient language, but it gives you, the user, Python so that you can write stuff in Python, and then behind the scenes it uses something faster like C or C++. So I think there's a lot of probably machine learning or AI stuff where it's Python, for example. Python, I think, is big in those domains. But it's actually, Python is hooking into certain C functions or maybe C++. I don't know the details because I don't do a lot of that stuff. But I just want you to know that Python is not going to be, in all cases, slower if it's some library where it's actually kind of under the hood it's using C or C++. So it I think the lingo is that it uses C hooks, something like that. So it doesn't, yeah, I'm just giving you that because it's an important exception to be aware of. So Python is not always guaranteed to be super slow in all contexts if that's what they're doing. Yeah, and I think that's it. So let me know what you think, because I need to have ideas of what direction to take this stuff if I continue to do it. And I'm just going to remove this main.py. We don't need it. There's definitely more stuff to teach as far as using the terminal, useful commands there. And obviously, with C, we're just getting started. But this is a very light introduction. If you followed along, you can write some basic C stuff. And actually, my most recent live stream, which was vertical format, I did some C stuff. And that's why I'm making this video, because I realized that somebody who's new is going to be pretty lost with the stuff that I was doing before. This was the code that I wrote in the live stream. This, don't worry about it too much. It takes a character, meaning like kind of one letter, and then it checks if that letter is a number, essentially, if it's from 0 to 9. We have our main.c here. It's a little it's a lot more complicated than what we did today. And it's not meant as a like lesson 2 here. I just dove into some stuff that I wanted to work on. This is just practice for me. So yeah, I think that's all I wanted to say. And I'll add one thing here before I go that's useful. All these commands have manuals. So you can type man ls, for instance. And you can go scroll through here with the arrows and read. So for example, we have these options. Flags, options. See, it calls them options. And there's going to be a lot of stuff here. Okay. You can press Q to quit, and that's it. We also use like pwd. We had make directory. We had cd, change directory. No menu. Oh, okay. Nothing for cd. I forget why. That's weird. pwd does. That's very unusual that you have a command like that that doesn't have a manual entry, I think. Make directory. We also had the rm command, which was important. It's also very important to be aware of the rm command because people, as a joke, write very dangerous rm commands because you can start deleting your entire system with this command. You need to be very, very careful if you use this command. So here's the manual for rm. You can also just Google these, and you'll get nice, better formatted little manuals. And most of these things are the same in Linux and Mac. This is more of a pretty advanced tip, but there's a command called sed, and there's also awk. These are really pretty advanced ones. They're almost awk is actually qualifies as a complete programming language because it's so powerful, the things you can do. These are for editing text, essentially, or like filtering text. And it's an advanced tip, but it's good to know there's different versions of these, and so they might be different, but there might be subtle differences between the Linux version and the Mac version, and stuff like that. But that's pretty advanced. Like almost nobody's going to run into this as a problem, but it's just useful information to tuck away, a little feather in your cap, because who knows, 10 years from now it might be biting you in the butt, costing you days of confusion because you didn't realize that the Linux version of these and the Mac version is subtly different. There are some slight differences. So useful information. Let me know what you think. Leave a like. Thank you. Have a great rest of the day.